Hello everyone, welcome to part 4 of our tutorial video. In this tutorial video, I will show how to use the Applied Motion Products AOI when using the MDX Plus and M5 servo drive with the Rockwell PLC. So in last tutorial video, we developed some of the programming using the AOI. So in this tutorial video, I will show how we can actually use the AOIs. So here is the application note 66 that includes the sample program in version 20 and version 32, and that is the sample program is the exact same as the demo setup that I have. So I will open the sample program and start working with the AOI. So here is the Studio 5000 software, and I have the MDX Plus and M5 servo drive, and I am connected to this network switch from my laptop. So then I will browse the RS Links Classic, and I can see that I have all the devices in the network. So I will find the PLC and then I will download the program. So now change controller to remote run mode. So in the section of the main program, I have two main routines. AMP servo axis 1 that is associated to MDX Plus, and axis 2 program is associated to with M5. So let's open the axis 1. So here in the axis 1 I have input assembly that gives all the feedback from the motor. The status code AOI gives the status bit representation of the motor, and the alarm code gives the faults and warnings from the motor. In the AOIs, like the enable and disable, they have all the basic functions. So let's start the enable first. So after triggering this AOI, we can see the status that motor is enabled. Now I will use the jog AOI. So here is the MP jog move AOI. So let's have the demo setup view. So the left side I have the demo setup, and it has the MDX Plus connected to rotary disk. So here is the rotary disk that is connected to MDX Plus motor. So I will keep the 5 RPS for the speed, and then once I trigger the jog instruction bit, here is the motor is jogging in the clockwise direction, and we can verify the speed, actual speed, by looking at the MP assembly AOI. Now to stop the jogging, we can either use the normal stop or a crash stop. So normal stop uses the deceleration rate, and the crash stop use the maximum deceleration. So I'm going to trigger the normal stop AOI. So as you can see, the motor stopped jogging. So that's how you can use this kind of AOI. So now I'm using the M5 servo drive that is connected to linear actuator. So here is the program of the AMP servo axis 2 routine that has all the AOI. So the motor is not enabled, so I'm going to enable the motor first. So let's trigger the enable instruction, and as we can see, the motor is enabled. So the motor is connected to linear actuator, and I can read the encoder position is approximately 21,000. So what I'm going to do is I'm going to move the actuator in positive direction of 10,000 counts. So that's the one rotation of the motor. So I'm going to use the AMP relative move AOI. So I will assign the distance to 10,000 counts, and keep everything is the same, and then I will trigger the AOI. So as you can see, it moved 10,000 count in positive direction. Next I'm going to move back negative direction 10,000. So once I trigger the AOI, you will see the caret will move to the negative direction. So the caret has moved to a negative 10,000 counts. So that's how user can use the other AOI. So the user guide inside the application note 66 is very helpful if user wants to know more about any of the AOI. It has the full description of functionality and the description of the parameters. That is the end of the tutorial, and if you have any questions or any concern, reach out to Applied Motion Products. Thank you.